we've got some pictures here made from blue marbles and red marbles. And I've sort of set it up to start with. Picture number 1 is called figure number 1. And we call it N, as we usually do. Figure number or picture number is always used often as N. In picture number 1 we have 4 blue balls and 1 red ball. Then what are we adding each time? This was our starting picture. We're adding 4 new balls and 2 new red balls. Okay, so figure number 2 has 8 blue balls, 3 red balls, and in total 11 balls. Figure number 3 has 12 blue balls. We had those to start with, so we stopped there. And again we added 4 blue balls and 2 red balls for the next figure. So we see our pattern here. Figure number 3 had 12 blue balls, 5 red balls, and a total number of 17 balls. So if we look at the pattern of what's happening here, well, blue balls is increasing by 4 each time. Yes? So it's really easy to come up with a formula for blue balls. So if we were to look at the formula for blue balls, because it's increasing by 4 each time, it's got to have 4n in it. So if I took figure number 1, n is 1, and multiplied it by 4, do I get 4? Yeah, 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. So I don't need any plus or minus there. So my formula for blue balls, number of blue balls in each of the figures, is 4n. Nice and easy. Okay? Then we go on to the red ball. And we think, what are we doing with the red marbles? We're actually adding 2 marbles each time. So we're going from 1 to 3 is plus 2, 3 to 5 is plus 2. This plus number here is very important for our series. It's telling us that in some way our formula for red balls must have 2 times the figure number, n. Is 2 times 1, 1? No, that would give us the answer 2. How do I get to 1? I have to subtract 1. If I had 2n minus 1 here, I would get the answer 1. What about if I did 2 times 2? That would give me 4. But if I took away 1, I'd get 3. If I did 2 times 3, I'd get 6. But if I did minus 1, I'd get 5. So this one is the formula for the red balls. So you take your plus number and then you adapt with a plus or minus so that you get the number that you're getting here. Okay, so now I have a formula for blue balls and red balls. It's actually very easy for me to work out the formula for total number of balls. Because if this is the formula for blue balls and this is the formula for red balls, all of the balls must be these 2 formulas added together. What is 4n plus 2n minus 1? Well, 4n plus 2n is 6n minus 1. So my formula that I think, and now I'm just guessing, that should work for the total number of balls, without even having looked at the total number of balls, the formula that I should be using should be 6n minus 1. Let's see if it works. What's 1 times 6? Whoops, down here. 1 times 6 is 6, but 6 minus 1 is 5. It works. 2 times 6 is 12, but 12 minus 1 is 11. It works. 3 times 6 is 18, but 18 minus 1 is 17. So the formula for all of the balls is 6n minus 1. Okay? Now we've got all this information, it's very easy to answer the question. The question in A was, how many blue balls for 10 red balls? Well, if we had 10 red balls, what figure number would that one have? 10 red balls. When would we get 10 red balls? Would we get 10 red balls? How many blue balls would be equivalent to 10 red balls. But we wouldn't get 10 red balls, would we? 1, 3, 5, 7, 9, 11. So let's, I think that the question is wrong there. I think we'll have to say, how many blue balls for 9 red balls? We'd have 5, and then next number would be 7, and then our next number would be 9. What figure number would 9 red balls have? Figure number 5. This one would be figure number 4. This one would be figure number 5. So figure number 5 would have 9 red balls. And how many blue balls would figure number 5 have then? So we know that we're at figure number 5. How many blue balls would figure number 5 have? We just use our formula, 4 times n. We know that the figure number is 5, so n equals 5. So the blue ball would be 4 times n, and we know that the figure number is 5. So 4 times 5 would be 20. So we'd have 20 blue balls in figure number 5. Then it said, how many balls in total would there be in figure number 20? No, in figure number 10. How many balls in total? So part B, how many balls in figure 10? All of them, both red and blue. Well, the nice thing is that because we did it this way, we've already got a figure, we've already got a formula for total balls. So if n equals 10, we know that the total number of balls is 6 times n minus 1. Wherever we see n, we put in the number 10 because we're trying to work out how many balls in figure number 10. Equals 6 times 10 minus 1. 6 times 10 is 60. 60 minus 1 is 59. So in figure number 10, there would be 59 balls. Okay? And practicing a little bit on how to make these formulas is very good practice. Become more and more of it in year 8 and year 9 as well.